once again Teacher Christy from Davao City National High School. Today, we will discuss the nature of roots of a quadratic equation, and it characterizes the roots of a quadratic equation using the discriminant. What I need to do. This activity is designed for you to evaluate the expression b squared minus 4ac given the values of a, b, and c, and determine the nature of the roots of a quadratic equation using the discriminant. Let's have a review. Write the quadratic equation in standard form, and our standard form is ax squared plus bx plus c equals 0. Then identify the values of a, b, and c. Let's have this example. 6x squared plus 11x equals 35. As you observe, this given example is not in standard form, so we must transform this into standard form. Like this, 6x squared plus 11x minus 35 equals 0. And now this equation is in standard form. We can identify the values of a, b, and c. Our a is 6, our b is 11, and our c is negative 35. Let's have another review on quadratic formula. Let's have this example. X squared minus 4x equals negative 4. If you can see, this given example is not in a standard form, so we must transform this into a standard form. Like this, x squared minus 4x plus 4 equals 0. We can now identify the values of a, b, and c, and our a is 1, and our b is negative 4, and our c is positive 4. And this is our quadratic formula. Our quadratic formula is x is equal to negative b plus and minus square root of b squared minus 4ac all over 2a. And we are going to use these values of a, b, c to substitute these letters here. Please observe, b, the value of b is negative 4. So we will write negative 4 in a place of b. And a is 1, we write 1 here. And c is 4, we write 4 here. And again, a, 1, so we write 1 here. And then simplify. Negative times negative 4 is positive 4. Copy plus and minus, and then simplify inside the radical symbol. Negative 4 times negative 4 is positive 16. Negative 4 times 1 times 4 is equal to negative 16. All over 2 times 1 is equal to 2. And then simplify the radicand. 16 minus 16 is 0. So we got x is equal to 4 plus and minus square root of 0 over 2. And then we know that square root of 0 is 0. From here, we will separate this plus and minus sign. X is equal to 4 plus 0 over 2, and the other one is x is equal to 4 minus 0 over 2. Then simplify. 4 plus 0 is 4 over 2, and the other side, 4 minus 0 is 4 over 2, and then simplify. So x is equal to 2. The value of x is 2. Now, let's go to discriminant of a quadratic equation. We use this formula. X is equal to negative b plus and minus square root of b squared minus 4ac all over 2a. For the roots of the quadratic equation of the form ax squared plus bx plus c equals 0, where a is not equal to 0. So the expression under the radical sign of the quadratic formula plays an important role in the calculation of the roots. So the value of the expression b squared minus 4az is called the discriminant. Again, the value of this expression b squared minus 4ac is called the discriminant of the quadratic equation. This value can be used to describe the nature of the roots of a quadratic equation. It can be 0, positive, and perfect square, positive but not perfect square, or negative. Please remember this. To solve for the discriminant, follow the steps. Let's have this example. Find the discriminant of x squared minus 4x equals negative 4. As you can see, this given example is not in standard form. So step 1, write the quadratic equation into standard form. From x squared minus 4x equals negative 4, use additive inverse. X squared minus 4x plus 4 equals negative 4 plus 4. Cancel this out and it becomes x squared minus 4x plus 4 equals 0. And this is now in standard form. So we can identify the values of a, b, and c. Then that is the second step. After transforming the given example into standard form, we can now identify the values of a, b, and c. From x squared minus 4x plus 4 equals 0, our a is 1, our b is negative 4, our c is positive 4. And these values, use these values to substitute to this equation. B squared minus 4ac. B squared minus 4az is equal to, the value of b is negative 4 squared minus 4, the value of a is 1, and the value of c is 4. And then simplify this. Negative 4 times 4, 16. Negative 4 times 1 times 4 is negative 16. So 16 minus 16 is equal to 0. The nature of the roots of quadratic. To describe the nature of roots of the quadratic equation, ax squared plus bx plus c equals 0, we use the value of the discriminant, b squared minus 4ac. Number 1. When b squared minus 4ac equals 0, then the roots are real numbers and are equal. Example. (25x squared minus 10x plus 1 equals 0). If you see this given example, this example is now in standard form. We can identify the values of a, b, and c. Okay, our b is negative 10, and our a is 25, and our c is 1. Simplify this. Negative 10 times negative 10 is equal to 100. Negative 4 times 25 times 1 is equal to negative 100. So 100 minus 100 is equal to 0. B squared minus 4ac is equal to 0. The value of b squared minus 4az is equal to 0. So therefore, the roots of the quadratic equation are real numbers and are equal. Again, if the value of b squared minus 4az is equal to 0, the roots of the quadratic equation are real numbers and are equal. Number 2. When b squared minus 4ac is greater than 0 in a perfect square, then the roots are rational numbers but are not equal. Example, let's find the discriminant and the nature of the roots. 7x squared minus 9x plus 2 equals 0. And this given example is in standard form. Using this expression b squared minus 4ac, use the values of a, b, and c to substitute here in this expression. Please observe, the value of b is negative 9, and the value of a is 7, and the value of c is 2. Simplify. Negative 9 times negative 9 is 81. Negative 4 times 7 times 2 is negative 56. 81 minus 56 is 25. The discriminant is 25, and it is greater than 0 and a perfect square number. Therefore, the roots are rational numbers but are not equal. Number 3. When b squared minus 4ac is greater than 0 but not a perfect square, then the roots are irrational numbers and are not equal. Let's find the discriminant and nature of the roots of this example. 6x squared minus 12x plus 4 equals 0. And this given example is in standard form. A is 6, b is negative 12, and c is 4. Using this expression, b squared minus 4ac, please substitute those values a, b, and c here. The value of b is negative 12, the value of a is 6, the value of c is 4. Then simplify. Negative 12 times negative 12 is 144. Negative 4 times 6 times 4 is negative 96. 144 minus 96 is 48. The discriminant is 48 and it is greater than 0. But 48 is not a perfect square. Then the roots are irrational numbers and are not equal. Again, the roots of this quadratic equation are irrational numbers and are not equal. Number 4. When b squared minus 4ac is less than 0, then the equation has no real roots. Let's have this example. 2x squared plus 8x plus 9 equals 0. Let's find the discriminant and the nature of the roots. We can identify the values of a. A is 2, 8 is b, and c is 9. Using this expression again, b squared minus 4ac, substitute the values of a, b, c here. The value of b is 8, the value of a is 2, the value of c is 9. Then simplify. 8 times 8 is 64. Negative 4 times 2 times 9 is negative 72. 64 minus 72 is negative 8. As you can see, negative 8 is less than 0. The discriminant is negative 8. Then, the roots or the nature of the roots of this equation has no real roots. Or this equation, 2x squared plus 8x plus 9 equals 0, has no real roots.